Solving systems of equations. A system of equations, a system is more than one. So we're solving a group of equations. We're trying to find, so for instance here, what x can we put in there, and the same x we'd also put in there, and we would get the same result, the same answer. So if I put in a 9 in here, I'll get 1/3 times 9 plus 3. I'll get some sort of number. And I put 9 in here, -3 times 9 minus 7. I'll get another number, and those will be different. So the goal is to try to find a number, an x, to put in here where they would spit out the exact same y. And we're doing this also thinking about absolute value equations. So an absolute value equation, we did this the last unit. Say we had something like this. We would first need to move over the 4 by adding it. So you get 11. And then we would create two equations. We would say the inside could be 11, but the inside, x squared minus 2x, could also be -11. And so we need to remember how to solve absolute values in this section, which is called solving systems of equations. Now, you can see here I've got an absolute value right there, and I've got one in there, so A, B, and C. But first, let's start out with one that doesn't have any absolute values. There's two ways to solve things. There's example number 1, solving systems by graphing, and you compare that to example 2, where right here, solve each linear system algebraically. So there's two different ways of doing this. Let's just zoom in here on example 1a. Now we need to solve this by graphing, so we need to graph this. I'll use a red pen for graphing the top one. Our starting point here, our b value is going to be 3, and our slope is going to be 1/3. 1 is our rise, 3 is our run. And it's a positive 1, so we'll go up. And when you run, you can run left or right, but it's a positive 3, so we will run right. So let's start here at 3, this graph. I'll have to zoom out a bit here. Start at 3. That's our y-intercept. It's our starting point at 3 here. And then we have to go up 1, 3 to the right. Up 1, 3 to the right. Up 1, 3 to the right. I'll keep the pattern moving down. Down 1, 3 to the left. Down 1, 3 to the left. Down 1, 1, 2, 3 to the left. So I have, it's really hard to connect the dots, but I have this line. Now, I have a second equation here. So this would be equation 1 in our system, and this is the second one in our system. This one has a starting point of -7. So I'm going to go down here, 1, 2, 3, 4, 5, 6, 7. Okay. And then I have a slope of -3/1. So our starting point was -7, and our slope was -3/1. And that's a rise over a run. Now it's a -3, so rising and negative would be going down. And this is still a positive 1, so we're going to run right. So from this, we're going to go down 3 and 1 to the right. So 1, 2, 3, 1 to the right. And I'm going to go up 3, 1 to the left. Up 3, 1 to the left. Up 1, 2, 3, 1 to the left. Up 1, 2, 3, 1 to the left. Up 1, 2, 3, 1 to the left. And hopefully you could have seen that these dots, that is where these dots overlapped. So I have this thing, this line, and they intersect there. And so what we need to know is the x value here. So 1, 2, 3, the x, and let's go, I'll go 1, 2, 3 in the negative x direction here, and then 1, 2. So our answer, which maybe I'll do in gray here, is -3 to the left and 2 up. That is our x, and that is our y. So if we take -3 and put it into this top one here, we'll have 1/3 times -3, plus the 3. You don't have to do this, by the way. I'm just proving a point. Negative 3 times the third would be negative 1 plus the 3. Negative 1 plus 3 is 2. So when I put negative 3 in, I get my y value equals 2. And if I put negative 3 into this one, negative 3, and then I put my x value, which is also negative 3 minus 7. Negative 3 times negative 3 is 9, minus 7. 9 minus 7 is 2. So we have found they both got 2. We have found that if you take negative 3 and put it into here, or if you put it into here, doesn't matter, you will get 2. So negative 3 gets the exact same answer for both questions in the system. And again, how do you see that graphically? Well, you look at where they overlap and you write down the points. They overlap at negative 3, 2. Now let's look at y equals, I'll do this in red, y equals the absolute value of negative 2x plus 1. So we have a starting point. Our starting point is our b, that's a 1. And then we have a slope of negative 2 over 1. And that's a rise. And this is a run. And that rise is a negative number, so we're going to head down. And we're running. A positive number is going to be right. So I'm going to start at 1. So start here at the y value of 1. We're going to go down 2, 1 to the right. Down 2, 1 to the right. Down 2, 1 to the right. And then up 2, 1 to the left. Up 2, 1 to the left. Up 2, 1 to the left. Now that would be it, just like that, except that it's the absolute value. And we learned the absolute values. You have to, any numbers that are down in the negative y's, remember this is the y-axis, anything that's down in the negative y's has to be flipped up. So we're right here, this dot right here is, we went down negative 1, so we're going to flip to positive 1. And then here we go down negative 3, so we're going to go up to positive 3. And then here we went 1, 2, 3, down negative 5, so we'll go up to positive 5. So our actual answer is you go here till you hit, and then you bounce right up and go like that. And so that is our equation. That is our first one, our absolute value. Our second one here is y equals x plus 1. This is the number in front of the x, by the way, is a 1, and all numbers can be over 1. So first we start with our b value, plus 1, and then we have our slope, which is 1 over 1. That's our rise, and this is our run, and they're both positive, so you're going to go up and you're going to go right. So we're going to start here at 1. Oh, that's right there. That's an overlap. And then we need to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And then down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. So we get this. And what people like to do at this point is flip it. Let's flip all of these ones that are down below. We'll flip them up. But look, there's no absolute values around here, so we actually have to leave it. So where do these things cross? Well, they intersect here, and they intersect here. So there's two spots, two answers. This dot, which is 0, 1, so over 0, up 1, that is a possible answer. That is a statement. If I put 0 into here, it'll work for both equations. And the other one is this dot, which is 2 to the right and 3 up. 2 to the right and 3 up. So those are our equations. Those are the x values, 0 and 2. And then if you put them in, you'll get a y value of 1 and 3. So this had two answers. It's nice to know. Now let's look at this one. So this is 1. Our b value is going to be negative 5, and our slope is 2. Now that's 2 over 1. So that's a rise, and that's a run. So you're going to rise up 2 and run to the right by 1 because they're both positive. So I'm going to start down here at negative 5. So negative 1, 2, 3, 4, 5. And then my slope is 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And then start back here, go down 2, left 1, down 2, left 1. Now I would think that would be it, except I think there's absolute values on it. So I'm going to have to flip everything that's negative. So this line goes like this, it hits there, now everything else has to get flipped up. So this is negative, it's going to go up to there. This is down 3, so we'll go up to 3. Down 5, so up to 5. Now you can see a pattern here. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So this is what our graph looks like because it's an absolute value. Now let's look at the second equation, number 2, in our system. We have to start at our b value. Our b value does not have the x, so this was backwards. It looks backwards here. So our b value is our 5. And our slope, our m, is negative 3. And that, again, is negative 3 over 1. So we're going to rise, and we're going to run. We're going to rise down 3, and we're going to run positive 1, which is right 1. So down 3, right 1, and we start at 5. So 1, 2, 3, 4. Oh, look, that's where they overlap already. Then we go down 3, 1, 2, 3, and 1 to the right. There. Down 3, 1, 2, 3, 1 to the right. Down 3, 1, 2, 3, 1 to the right. 1, 2, 3, 1 to the right. Now back here, 1, 2, 3, 1 to the left. 1, 2, 3, 1 to the left. And if you had a ruler, it's harder to draw this on, like I said, on a tablet. You can see here that they only cross once. If you can draw a straight line, so they cross here, and then you can look, they're getting further and further and further apart. And here they're getting further and further apart, and then here that one just heads straight down. This one's heading up. So they only cross once. And that point is 1, 2, 3, 4, 5. So over 0 and up 5. And so that's the x value. The x value is 0, and that is what allows us to get the same y in both equations, that y value being 5.